Okay, so Pushpak, you can start your presentation.
Is my screen visible now?
Yes, your screen is visible. You can continue.
So, good evening, ma'am. Uh, Today I'm Pushpak Suryawanshi, and today I'm going to present a PPT, a presentation on the topic predictive modeling. I'm from the machine learning and deep learning group. So these are the contents of the slide I'm going to present. First is introduction, then a little bit about the predictive modeling, then the task given to me, then the methodology I've used in this task to complete this task, then the results and outcomes of the task and the code, and finally the conclusion. So first, let's start with the introduction. So today we are going to see the world of predictive modeling. So predictive modeling is a powerful tool in the field of data science and machine learning. It is mostly used for the decision-making process. So in an era driven by the data, predictive modeling empowers us to extract valuable insights and make informed decisions, which will help help us in future decision making. So let's embark on this journey to understand what is predictive modeling and how it can help us to improve the process of decision making. So let us see what is predictive modeling first.
1 minute. Are you changing your slides as well?
Yes, ma'am.
Actually, I cannot see the changing slides. Is there any
Uh,
net issue from your side?
okay. Can I reshare, ma'am?
Yeah, sure.
Just a minute, ma'am. Ma'am, now is the screen visible?
Yeah, now it's visible.
Yes. So yes, ma'am. So sorry, ma'am, for the disturbance.
No problem. You can continue.
So this was the first slide. So this was a table of contents, introduction, predictive modeling, the task given to me, the methodology I've used in this task, the results and the outcomes of the code, and the conclusion. First, let us look at the conclusion. No, the introduction first. So I've explained this that today we are going to look at a decision, the predictive modeling phase, which is an important tool in the field of data science, which helps us to maintain decision making and make informed decisions. So secondly, let us see that what is predictive modeling. So predictive modeling is the process of using historical data and statistical model algorithms like machine learning algorithms to make predictions about the future events or outcomes. So it is an important branch of data science that helps businesses, and it is used for many applications such as healthcare and healthcare defense, and it helps many organizations in decision making, and it uses machine learning techniques, statistical analysis, and domain expertise to create predictive models. So these models can be applied in various fields from finance and healthcare to marketing and manufacturing. So the main advantages of predictive modeling are improved decision making, risk assessment, resource optimization, customer segmentation, and forecasting and trend analysis. So we are going to today see the forecasting and predicting future events. So this is the full process of predictive modeling. So next is, let us see the task given to me. So the task given to me was first, the dataset was given to me by Hackveda, was the student performance dataset from Kaggle. So the task was to build a predictive model to predict the math score of a student based on other variables such as gender, race, ethnicity, parental level of education, lunch, and test preparation course. Then the task was to use supervised machine learning algorithms such as logistic regression, decision trees, and random forest and XGBoost to build the model. And finally, the task was to evaluate the model and use feature selection techniques to identify the most important feature for predicting the math score and make decisions. So the next step is methodology that I've used in this task. So let us first look at the data set. So the data set consists of the data set consists of marks scored by the students of a school. So it consists of columns such as gender, whether the student is a male or female. Secondly, the race to which the students belongs. Next is the parental level of education, where which describes the level of education of the parents, such as bachelor degree or some college or high school or no education, etc. Then the lunch that the students prefers in the school, which are whether it is a standard or free or reduced. Next, in the test preparation course, whether the student has studied or completed the course or no. Based on that, the student got the score such as math score, reading score, and writing score. So here the task allotted to me is to predict the math score only. So let us see the full methodology. So first, the uh, task is to gather the data. So the data is already given to me by Hackveda. Then the next step is data cleaning to fill some missing values or to drop missing values or to drop invalid data, incomplete data, etc. Then the task is to perform EDA EDA, then to build the ML models, machine learning models, then to evaluate the model based on various performance metrics, and then finally a feature selection to identify the most important feature to predict the math score. So we'll see these all these tasks, all these subtasks in detail in the next slide. So first task is data gathering. So what is data gathering? So data gathering involves collecting relevant data from various sources such as databases, APIs, Excel files, text files, surveys, and also sensors. It can be of many types, such as it can be in the form of Excel files or images, videos, etc. So it is the main steps. Uh, uh, it is the most it involves data collection, it involves data collection from various sources. So it is a little bit time consuming step. So to for optimal performance of the machine learning algorithms, we need high quality data. So data gathering. So there are many challenges in the data gathering phase, such as data volume, data variety, and data velocity. Data volume consists of the volume of data. If there are lakhs of rows of data, it becomes very difficult to apply algorithms and analyze this data, as the data set is very large, and to clean such data is an exhaustive process. So it is a big challenge for such a large volume of data. Then second is data variety. So in this era of data, there are many varieties of data, such as images, audio files, video files. So to extract important data from it and to analyze it becomes a major task. So data variety is a big challenge. Then the last challenge is data velocity. So the speed of data, the speed at which data is produced at real time, and adds up to a lot of data. That is a real challenge. So these are the three V's of data, big data, which we call three V's, are which we need to consider while doing data analysis. And for the analysis of big data, these are the three V's which are very important and to be taken into consideration. So next step is data cleaning, which consists of identifying and correcting error or inconsistencies in the data set. So it involves many tasks like handling missing values, removing duplicates, and standardizing formats. It also includes removing incomplete data or removing invalid data, and cleaning the data also includes the making the data uniform and maintaining data coherency, etc. So benefits of data cleaning includes that it improves model accuracy, it enhances data quality, and it also reduces bias in predictions. So next step is EDA, exploratory data analysis. It's a very crucial phase in the data analytics, and it involves creating summary statistics, data visualizations, and identifying patterns in the data, which helps us to understand to understand the data set more, and we can also extract valuable things from it. It involves three phases: univariate analysis, bivariate analysis, and multivariate analysis. Univariate analysis consists of taking each feature independently and performing analysis according to it. Bivariate analysis consists of taking two columns at a time and comparing them and extracting most valuable features from it. And multivariate analysis consists of taking one or two or more features and finding the correlation between them. So next step, and the most important step in the field of predictive modeling, is model building. So model building is where we truly truly predict something and and it is the most important step in decision making process. So it involves us selecting the right algorithms and features to create a predictive models. So in this task, we are going to see various machine learning algorithms such as logistic regression, decision tree, random forest, XGBoost, and SVM, SVR, etc. So next step is the model evaluation. So model evaluation is something that it tells us about uh, how good a model is, and according to it, we can find that which model is the best suitable for us, and according to it, we will consider that model uh, for uh, for a recognition of the data set. Then common evaluation metrics includes accuracy, precision, recall, F1 score, R square score, RMSE. RMSE means root means square error, and ME mean absolute error also. These are some of the performance metrics used to evaluate the model. Also, cross validation is a important performance metric which helps in estimating model performance on unseed data. So on the side, we can see this is called the confusion matrix, which is very helpful for identifying which values are which predictive values are very accurately which accurately align with the uh, original data, which and we can also see the various formulas of accuracy, specificity, precision, and recall. Then below the formulas of mean absolute error, mean square error, root mean square error, and R square error. So these are the important performance metrics to evaluate the model. So finally, we have done the feature selection. In feature selection, what we do is we identify the most important features required for predicting the math score, and we will see which are the most important features and which are the less important features which do not perfectly predict the model, and which are of no value. So following are the feature selection techniques, which are univariate selection, feature importance, and correlation matrix. So the best suitable feature selection technique here was univariate selection. So in this task, we have used that. So finally, result and outcomes. So before result and outcomes, I want you to see the code. So this is the code. So first, what we do is we import the necessary packages related to for building the models and data analysis. So next step is to load the data set. Then we take the basic data set overview and the summary of the data set. First, we print the first five rows of the data set. So these are the first five rows of the data set. Then we generate a small summary of the data set, that what is the data type of it and how many rows does it contain. So from here we can see that the data set consists of over 1,000 rows, and here is the data type, that all the features are of object data type, and only the scores data type are of integer data type, so which is correct. So and then we have generated a small another small summary, statistical summary using the describe function. So in describe function, we can see that how many unique values are there, what is the 25th, 50th, and 75 percentile of the data. So it properly describes that. Next step is the data cleaning phase. In data cleaning phase, we check for null values if are there or not. If there are any null values, we remove it. So we can see that all values are zero, which means that there are no null values in the data set. Next, we rename the columns for a more understandability. We just use the underscore in between the words to improve the understanding, and to for proper utilization in the next lines of code, which will not create any confusion. So we print the columns to understand which are the columns. Then we do the next step is to do the EDA. So in EDA, there are three phases: univariate analysis, bivariate analysis, and multivariate analysis. So first is univariate analysis, in which we take each column, each feature, and analyze it, extract the most important information from it. So first, we use the gender column and find the count of how many female students are there and how many male students are there. So from this, we get the data that female students are more than male students. So female students are more than 500, while male students are a little bit less than 500. So next step is to use the race ethnicity column. So we can see that we have used the count plot here. So we can see here the students from the group C race are the highest, followed by group D and group B. So this is the information that we get from this graph. Next is the type of lunch that student prefers. The standard lunch are preferred by the most of the students. Then the test preparation course, that how many students have completed the test preparations and how many of not. So we can see that students that took that test preparations course are less than students who didn't. So there are only less students who took the who have completed the test preparations. Next, this concludes the univariate analysis phase. Then let's move the bivariate analysis. So in bivariate analysis, we take two columns each. So we have plotted the pair plot here, which take two columns. So here is the reading score and math score, writing score and reading score. So we have generated this score to find out that which two scores have the most correlations between them. So we can see here the reading scores of female students are more than the male students, while the math scores are also more, writing scores and reading scores are equal in both students, but the math scores and writing scores are more in female students than male students. So this graph properly indicates that. So next we plot a small box plot of all the features and the math score particular. So we can see here the median math score of students whose parents have master degree uh, and did not no test preparation scores have the highest mean value. So we can see the bar here. The students whose parents have master degree had did no test preparation scores are the highest. So same we have done for reading score and the writing score as well. So here is a next we have plotted a violin plot. This violin plot indicates that the student from race E have have most math score from 70 to 90. So these are male students. So same likewise we have done the reading score for and writing score also. We are presently concerned with math score, so let us focus on that. So we have this concludes the phase of bivariate analysis. Finally we do the multivariate analysis. So here is a small heat map which indicates the correlation of all the features with all the features. So we can see here the reading score and the writing score, sorry, the math score, the the reading score and the writing score and the math score are highly correlated with each other. We can see here the reading score and the writing score have a positive correlation of almost 0.95, which is a good thing, which means that a student having a greater writing score also has a greater reading score. So this heat map indicates that which values are highly correlated with each other, which features are highly correlated with each other. Next is a joint plot. So joint plot, we have plotted between math score and reading score. We can see here the maximum distribution of the reading and writing score fall between 60 to 80. The black spot indicates the value which are mostly concentrated. Same we have done for math score and writing score. Here the values are mostly concentrated between 60 to 80, same. And finally, for the reading and writing score. So next we have calculated. We have done the group by on the test preparation scores that which students have completed how many students have completed the test preparation score, and accordingly we have calculated the mean. So from this three results, we can see that the mean of maths, reading, and writing score of students that did not do any test preparation score is relatively higher than students who did not. So it indicates that by doing the test preparation score, the students are scoring more marks. So the next step is building machine learning algorithms. So first we divide the data set into X and Y variables. Here is the categories. While building the machine learning algorithms, the most important step is to here are the categories. So we have to first convert into binary values, zero ones values, as the algorithm only understands the binary values and not the categorical. Such as bachelor degree, some college, master degree, standard, free, reduce. The algorithm doesn't understand that. So we have to convert all these values into zeros and ones by using the one-hot encoder. So we have used a one-hot encoder standard scaler here to bring such values into zeros and ones. Next, we split the data set into training data set and testing data set. Training data set means the data set in which the model is going to train on, and the testing data set means the model which we are going to test. Finally, based on these values, we are going to predict the testing values. So these is the evaluate model to evaluate the model. So we have considered four metrics here: mean absolute error, mean square error, root mean square error, and R square error. And then we apply machine learning algorithms. So we have we have taken many models here: linear regression, lasso regression, ridge regression, KNN model, decision tree, random forest, XGBoost, logistic regression, also AdaBoost. So we train the data set in all these models, and finally we get this result as it generates a full summary of what a particular model performed and what we get the evaluation metrics of that model. So we can see here the best model that performed in this data on this data set was the ridge regression model, followed by linear regression and random forest. The for ridge regression we got the R square score as 0.88. So R square score is an evaluation matrix. So for a model to be performed too well, to do well, the R square should be R square score should be closer to 1. And the more it is closer to 1, the better the model performs. And the more it is closer to 0, the worse the model performs. So the ridge regression models has the highest R square score, and it consists of almost 88%. So the model has performed predicted 88% more accurate and if we compare the predictive values and the original values, the difference between the predicted and original values will be less in case of ridge regression. So this is a scatter plot of actual and predictive values. So we can see that the scatter plot, the actual and predictive values. Then we have calculate a regression plot based on same values. Then we this is the most important plot, a table that describes that what is the actual difference between the actual value and the predictive value. So we can see that the difference is very less. In some cases, the difference is also 0, which means it is a great thing, which means the model performed very well. So, and finally, we applied the feature selection technique. In this task, we have applied the univariate selection, which because it is the best suitable for this data set. So the selected features, we get an array that is true false, which means that the feature means the column which are most important for predicting the math score. So we can see that true for is the gender column, and these two trues are for these two trues are for the I think the lunch column, and these remaining trues are for the reading scores column, and these false are for the parental level of education, which means that the parental level of education does not is not needed for predicting the math score. So this feature selection indicates us that. So moving back to the PPT, we get these conclusion made during the data cleaning and exploratory data analysis, which we have already seen in the code. So this is the output of all specific subtasks. This is the output of how well a model performs. This is the final output. These are the two plots, and these are the output of the feature selection. Finally, the conclusion. So in this task, we have performed predictive modeling, which included subtasks like data gathering, data cleaning, EDA, building machine learning algorithms, model evaluation, and feature selection. So from out of the all machine learning algorithm models, the ridge regression performed best, followed by the linear regression and random forest. We have already seen this in code. Also, we have finally performed feature selection to find out the best features, such as gender, parental level of education, reading and writing score required to predict the math score of the students. So these are the list of references from which I have taken some information from to make my PPT. So this is the question and answer slide. If you have any questions, please feel free to ask here at my email ID. So thank you, everyone. This was all about the presentation. Thank you, ma'am.
Okay. Are you done with the presentation, Pushpak?
Sorry, ma'am.
Are you done with the presentation? Have you
Yes,
completed?
ma'am. Yes, ma'am.
Okay. So let me know once that your presentation is scheduled for which date? For this topic?
Predictive modeling.
Yes. Is it scheduled for 19th September, if I'm not wrong?
Yes, ma'am.
Okay, perfect. Okay, so in your last conclusion slide, you mentioned that there were no null values in your data set. So
Yes, ma'am.
suppose if there might be null values, so what techniques you would have implied to remove those null values? Any idea?
Ma'am, that comes in the data cleaning phase. So if there are any null values, we can apply two techniques for it. So first technique is that if the null values percentage is very low, then we can drop those null values. And second technique is that if the null values percentage is more, we can fill the data null values by three techniques. Then the three techniques are that we can fill those null values by mean of all the values, or median of all values, or mode of all values. So these are the two techniques which are most used for filling the null values.
Okay, okay, fine. Rest your presentation was good as you gave yesterday, or I guess day before day, and your
Yes, ma'am.
demonstration part also quite clear. So, do you have any questions?
No, ma'am, no questions.
Okay, okay. So I will provide your scores and feedback on your email.
Okay, ma'am.
Okay. Okay. Next we have Sunita. You can start your presentation.
Okay, ma'am. Good evening, ma'am.
Good evening, Sunita.
Can I share my screen, ma'am?
Yeah, yeah, sure.
Ma'am, is it okay?
Yes, yes.
Okay, ma'am. Good evening. Myself, Suryawanshi. I completed my BTech in 2023 at Jawaharlal Nehru Technical School
Sorry
University.
to interrupt. Turn on your camera, please. Yes.
Okay, ma'am. Ma'am, am I visible?
Actually, you're not visible. I can see the black screen. I mean, yeah, now perfect. Continue.
Ma'am, now?
Yeah, yeah. Go on.
Okay, ma'am. I am from Embedded Systems and Laboratory branch of Hackwada. Today, I presentation is about developing a component specification document for an air quality monitoring. So first we have to look at the contents of my documentation. These are the contents. What is air quality monitoring? Purpose of air quality monitoring, block diagram, types of air quality monitoring, key components of air quality monitoring, brief explanation and specifications of key components, circuit diagram, conclusion and references. What is air quality monitoring? Air quality monitoring and air pollution monitoring is the process of sampling and testing of air emissions. Excuse me. Sorry to interrupt. Air quality monitoring and air pollution monitoring is a process of sampling and testing of air emissions. Due to so many factories or vehicles, fossil fuels, so many gases are releasing on the atmosphere, and we have to monitor the air pollution. That's why we need to take air samples, and we have to do some practicals and analyze the data on air. And by knowing the data, we can estimate how much pollution is there and what is the we are in safe mode or we are in danger mode. We can know that. So that whole process is nothing but air quality monitoring. Once air pollutants are emitted, they are influenced by weather conditions. We know that weather at the all over the world is not same. So only taking air samplers at one station is not enough. We have to monitor at everywhere. Everywhere in the weather in all around the world is extremely variable. Here the air quality monitoring is comes into picture. Once pollution it can also help us to determine which area in the country is producing more air quality pollutants and which area is safe and where we can take precautions to reduce the air pollution. The air quality data can be used in many ways, like what will be the percentage drop in pollution if traffic reduced by 50%. Like if you want to forecast the future situation, like the air pollution level is increasing day by day, and we estimate that like if you reduce the industries or if you reduce the fossil fuel usage, can we drop the air pollution percentage? That can be known by air quality monitoring. Air quality monitoring is nothing but giving data about air quality emission, air emissions in the weather. So by estimating these methods, we can forecast that can we reduce the air pollution or can we take any precautions to reduce that? That can be known by air quality monitoring. And purpose and benefits of air quality monitoring. Air quality monitoring is the process of measuring various pollutants present in the air. These pollutions can have significant impact on human health and the environment. We all know that the air is the primary factor to live the human beings. So monitoring this pollution is very important for our health. And there are many benefits by monitoring the air. We can see some of the improve air quality. By monitoring the air, we can know how much pollution is present in the air. So by taking different measures or by reducing the pollution level, we can improve the air quality. Monitor compliance with regulations. Air quality sensors and other devices make it possible to keep an eye on emissions from industrial sources such as power plants and factories to ensure they meet the standards set by government agencies and adjust your outdoor activities accordingly. One of the main benefit of air quality monitoring is that it helps us to ensure that the air we breathe is safe. Suppose if you by monitoring the air, we can know it's run in a safe mode or it's in a dangerous mode. By measuring the air quality level, if this crosses the government limits, Actually, they have some standards like the air quality ppm should be in this limit, and air quality pollution level is in this limit, the PBL level in this limit. If the air quality crosses these limits, then we can easily forecast there is some danger in air quality, so we can elect the people. Whatever it may be, we can take some safety measures. Monitor climate changes. Based on climate changes, the air quality emissions also increasing. Like for some place, the air quality is somewhat level, and in another place, the level is different. So like if the air quality pollution is very high, then we can reduce the pollution at that station or at the surroundings. That can be switched into safe mode. Support research and development. Collected data on air quality is a unique source of inspiration for research and development of new pollution control technologies that have the potential to reduce emissions from the industrial sources. This provides a support research and development because collected data on air quality monitoring can be analyzed, and research can be done, and we can develop so many methods how you can reduce the emissions and what emissions are there. In order to reduce that, what measures we have to take, and protect health. By knowing the air, we all know that health is important factor of human beings. So by monitoring the air quality level, we can protect our health. With the increasing awareness of health and impacts air pollution, learning about the benefits of air pollution control is more important than ever. The main purpose of air quality monitoring is to improve air quality, protecting public health, and ensuring compliance with regulations. And here we can see this is block diagram of air quality monitoring. The block diagram includes input devices and output devices. Here the input devices are sensors. Sensors can be many types. Like if you want to know the carbon dioxide level in the air, and we can use carbon dioxide sensor. If you want to know particulate matter present in the air, we can use particulate sensor. And if you want to measure smoke sensor, we can use smoke. In order to smoke, we can use smoke sensor. Not only these three types, there are so many toxic gases are present in the air like ozone, carbon monoxide, sulfur dioxide. These all can be measured by different sensors. And this input can be given to the Arduino. Arduino processes this data and gives output to the LCD display, like what amount of air pollution is level can be displayed on the LCD display. And data logger is used to save the data. If you want data logger can be save the data from 6 months or 1 year. Based on our settings, it can store the data. If you want to forecast the future, we want to analyze the past data. So if you want to retrieve the past data logger can be used. And GPRS modem is to provide communication in the wireless form. If you want to communicate or interface any devices to the Arduino, we can use GPRS modem, and we can build this simple block diagram. And types of air quality monitoring. There are mainly 4 types of air quality monitoring. Here we can see first one is stationary source emission. Stationary source emission is nothing but if you have any factory, the emissions are like through chimney or the devices, the emission is not moving. It produces on a single place. So in order to monitor that, we have to go that place and build a air quality monitoring system, and we have to monitor that air. That is stationary source emission. Here we can see that in order to monitor this air, we have to go this place, and then we can monitor the air. Ma'am, my voice is okay?
Yes, sometimes it's breaking, but for now it's quite fine.
Okay. And next one is on-road monitoring. On-road is nothing but it can monitor the moving air. Like can we see on roads? The air is somewhat fluctuating, and the moving air monitoring is nothing but on-road monitoring. We can see these stations on roads. This can, if any limits cross on air pollution level, then they can elect the people, like some measures can be implemented, like use bicycles, don't use motorcycles. Um, like they said that reduce the consumption of fossil fuels that can affect our health, and maybe the gases produced into environment can be reduced. And ambient air quality monitoring. It collects an ambient as information. Ambient air quality monitoring is nothing but outdoor air quality monitoring. Actually, it has some standard values, like the air quality level in this place or in this station is like some standard, and it compares the present air quality pollution and past data. By comparing this can give errors, or this can intimate any alarm. In this way it works, and it is required to determine whether a geographical region or area is meeting the national ambient air quality standards. And this is one of the organization which provides the standards of air quality pollutants. And if there any measured value crosses these limits, we have to immediately take action, and we can take safety measures. And this outdoor pollution monitoring is used for carbon dioxide measuring, oxides of nitrogen and ozone, lead, particulate matter, and PM2, PM2.5. These are one of the sensors. This can be used for sulfur dioxide and volatile organic compounds. Remote sensing and satellite monitoring. This is nothing but collecting a entire place or entire state or entire, like if you want to take any country air quality level, we can choose this method. Yeah, it gives average of air pollution level. Like if we want to measure the pollution level in India, then we can measure each state pollution level, and we can take average of that. In that way, we can know the how much overall pollution level present in India. And key components of air quality monitoring. There are some small components also are there, but these are main components of air quality monitoring. First one is Arduino. Here we can see this is Arduino. Arduino, there are so many types like Atmega Arduino, Arduino UNO, and for our purpose we use Arduino UNO. Here this is Arduino UNO diagram. There are some pins. A0 to A5 is nothing but 6 analog pins. We can give input to these pins, and in order to power on the Arduino, we have to give ground and supply. Supply can be given at V input 5 volts, and ground can be connected to ground. And these are the 3 volts and 5 volts. Like if the wants 3 volts, it can be taken from this. And if it wants 5 volts, it can taken from this. And here are digital pins. Digital pins can be used as input or either output. And I2C clock. I2C clock is for given clock to this. And digital pins can be used for serial peripheral interface. SPI is nothing but serial peripheral interface. If you want to interface any devices, we can interface with this. And in order to interface, we have to choose these 4 modes. And here receiver and transmitter pins are there. In order to receive data, we can enable receive, and in order to transmit data, we can enable transfer. Arduino is nothing but one of the platform that provides communication between both hardware and software. In order to implement any project or any whatever you project you need, we can implement by giving input instructions, and by taking output instructions from the Arduino, we can build that. Arduino boards can read inputs from light sensor, finger on a button, or a Twitter message, and turn into an output like activating a motor, turning on a LED, publishing something online. Not only this one, like by to output in the form of we can get in the Arduino. And Arduino is a page of from we observe that nowadays students or professors or program all over the Arduino usage is very high. There are many other microcontrollers and microcontroller platforms available for physical computing. Like without Arduino, we can do some projects, but particular languages like that we can nowadays we can't see that languages, and Arduino is not like that. Arduino we can program the Arduino by using whatever language we can know, like C or Python. In whatever it may be language, we can give instructions to the Arduino. And these are some key features of Arduino. Inexpensive. Arduino boards are relatively inexpensive compared to other microplatforms. The least expensive version of Arduino module can be assembled by hand, and even the pre-assembled Arduino modules cost less than $50. The cost of Arduino is very low. Compared to our application, Arduino can provide a best platform, and in that can be get by at very low cost. And cross-platform. Cross-platform is nothing but Arduino cannot be limited for Windows. It can be used on Linux. It can be used on Macintosh OS X, and this can be used on any platform. Simple and clear programming environment. We can easily give instructions to the Arduino by using simple languages. And if you know any programming language, we can easily code that Arduino in what way we require that. Open source and extensible software. It not only limits for only professors can use it, or only some authorized persons use it. It's not like that. Arduino is a open source and extensible software. Anyone can want to encode it, we can encode it, and if anyone want to use it, easily we can use it. Open source and extensible hardware. The plan of the Arduino boards are published under Creative Commons license, so experienced circuit designers can make their own version of module, extend it and improving it. Like if any person want to make some changes in the Arduino programming, then they can easily access that and changes can be made. And these are the specifications of Arduino. Clock speed is 16 megahertz. It's nothing but number of cycles per a second. And operating voltage is 5 volts. Already we saw that. Maximum supply volts is 20 volts. If the limit is crossed its limit, and Arduino is damaged. And supply voltage is 7 to 12 volts. Analog input pins are 6. We are see that A0 to A5 are the analog pins, and digital input output pins are 14, D0 to D15. DC current, this is the current input to the Arduino, 40 milliamps, and DC current in 3.3. We can see 5 volts pin and 3.3 volt pins. For 3.3 volt pin, 50 milliamperes. And SRAM is nothing but static random access memory. This is 2 KB. And EEPROM is electrically erasable memory. This is 1 KB. And this is flash memory. Flash memory is 32 KB. Sensors. Air quality sensors are devices used to detect the contaminants in the air. Is nothing but the emissions in the air, or the hazardous matter or toxic gases present in the air. This includes particulates, pollutants, and noxious gases that may be harmful to human health. They are used in applications like air quality monitoring, gas detection in industry, combustion controllers, and oxygen generators in aircrafts. Some of the commonly used sensors are ammonia sensor. Prana Air's ammonia sensor is a combination of mature electrochemical detection technology and sophisticated circuit design. It is a tightly combined module designed and manufactured for general purpose and industrial gas modules. For general purpose and industrial purpose, we can highly use ammonia sensor. Ammonia sensor working principle is electrochemical ammonia gas module. It is nothing but actually ammonia is a colorless gas with a strong noticeable smell that causes air pollution. It is an alkaline gas that is present in the atmosphere emitted through livestock waste management, agricultural activities, and some pesticides. The sources of ammonia are agricultural activities and some pesticides. It remains in the air for a few hours, but it reacts to the other pollutants in the short amount of time interval that is that harmful to the poisonous for human to inhale. Like ammonia itself is not harmful to our health, but after ammonia releasing to the atmosphere, it reacts with the surrounding chemicals and uh, then it produces very harmful and poisonous for human to inhale. And this is the diagram of ammonia sensor. And next sensor is carbon monoxide sensor. When carbon monoxide enters the gas permeable component that houses the sensor, that is nothing but when carbon dioxide is surrounds the sensor, a chemical reaction occurs that causes the electrical current passing through the electricity to surge. The specific amount by which the current increases tells the detector the concentration of carbon dioxide monoxide molecules. Actually, carbon monoxide sensor is worked on electrochemical principle. Is nothing but when the carbon dioxide is surrounding the sensor, the sensor senses the carbon dioxide, and based on level of carbon dioxide, it provides a current. And if the current limit is beyond the any standard value, then we can identify that carbon monoxide level in the air is increasing. Here we can see that carbon monoxide sensor module works on electrochemical principle. It works based on the diffusion of CO gas into the sensor, which results in the products of an electrical signal proportional to the CO concentration. Here electrical signal is a current. If the carbon monoxide in the air increases, then the current produced in the sensor also increases. By observing the increasing current value, we can know that the carbon monoxide value in the air increases. And this is how this sensor works. And this is diagram of carbon monoxide sensor. And next one is ozone sensor. Our ozone sensors and monitoring systems are widely used across a range of applications, from industrial hygiene to virus disinfection and this sterilization of commercial and residential buildings. Gas sensitive semiconductor technology enables accurate parts per billion. This is one of the units for measuring the air pollution detection at a fraction of the cost of analyzer based instruments. Employees, health and safety managers, and air quality professionals around the world use our best in class ozone sensor technology to protect worker health and achieve regulatory compliance. Our portable ozone monitors are widely recognized and used for its proprietary best in class ozone technology that delivers highly selective ozone measurement at low concentration. They can be used both indoor and outdoor monitoring. Actually, ozone sensors can be classified into two types. One is fixed air, in another one is movable. Fixed ozone meters are designed to measure and control ozone concentrations so that you can control an external device such as an ozone generator. By measuring the ozone from a fixed zone, we can control the ozone generator and activate an alarm if needs and monitor ozone level for health and safety. And this is diagram of ozone sensor. Actually, these are 5 pins. One is VCC and another one is ground, and another one is input output like transmitter and receiver. These are specifications of sensors. Technical indicators of 50 ppm NH3 sensor. NH3 sensor can be measured. ppm is also one of the unit for air pollution, like parts per million. NH3 sensor can measure up to 50 ppm, and resolution is 0.01 ppm. Output data, UART output 3.3, voltage can be 3.3, and response time should be less than 30 seconds, and recovery time should be less than or equals to 60 seconds. Sensitivity of the sensors are 200 millivolts. This is very low, so we have to handle it carefully. And service life is 2 years, and operating temperature is minus 20 degrees Celsius to 50 degrees Celsius. Here, the temperature monitoring is also very important because this is all based on chemical reaction. If the temperature range is not like that, then the output values can be changed. And operating humidity range is 15% RH and to 90% RH. Operating voltage is 3.7 volts to 5.5 volts. We cannot operate beyond 5.5 volts. And module size is this one. And next is filters. The system consists of 2 primary components, a filtering unit and an air quality monitor. The filtering unit consists of a dust filter, pre-filter, and fine filter. These are some important parts of filtering. They are dust filter and pre-filter and fine filter. Depending on the dust sensor measurement, the software automatically on and off the air purifying unit based on the threshold. Based on the pollution level, filters can be automatically on or off. For the purpose of detecting a variety of gases such as NH3, NO, alcohol, benzene, smoke, CO2, this smart air purifier employs MQ135. MQ135 recommended because it can measure even small pollutants like micrometers can be measured by MQ135 properly. The air pollution and particulate matter present in the environment are found using the air quality monitoring unit. The prototype of this sensing device is tested to validate the system's functionality. The results shown by this device are promising for daily air quality monitoring. The filtering is nothing but we can filter very small particles in the air, and by analyzing the filtering particles we can analyze that there are somewhat level of pollution and how to monitor it. And this is diagram of filtering. Here the air can be inletted through this pipe, and we can see that there are some levels of filtering like visual impactor nozzle. When air passes through this nozzle, some impurities can be filtered, and coarse particles like particles which have size less than 2.5 micrometers to the 10 micrometers, that particles can be filtered here, and fine particles like less than 2.5 micrometers, and after passing through these 2 nozzles, then it comes to down, and here we can measure some particles like 37 diameter, and this is last level of filtering. And after filtering, the air can be again measured and analyzed that before and after how much amount of particulate matter present in that air. By knowing after filtering value and before filtering value, we can easily identify that how much amount of air pollution is present in that air. And these are the specifications of filters. Alkalinity max, it is 25 mu equivalent. And pore size of this is 2 m. In the diagram we saw that it can measure only less than 2.5 μm. The pore size is 2 micrometers, and it provides a supporting ring system. The material used for supporting ring is polypropylene PP, and supporting ring width is 3.68 mm to 0.00 to 0.51. And last one is analyzers. Analyzers are nothing but after filtering, we have to monitor that how much amount of particulate matter or how much of pollution is present. And by knowing this all data in this process, analyzers analyze that and analyze and gives output to the LCD or any display or any alarms like this much amount of pollution is present in the air, and this method we have to take in order to reduce that. In this context, air quality monitors networks play a crucial role in measuring and monitoring outdoor air quality. Fixed measuring stations with appropriate instrumentation are strategically located to collect real-time data on the levels of air pollutants, mainly gases and particulate matter. The data obtained is analyzed and used to generate reports and early warnings to excessive air pollution levels. Here we can observe that the data can be analyzed and used to generate reports. In order to forecast, or we can analyze the data in the form of bar graphs, in the form of pie charts. So by analyzing in different methods, we can know more about the air pollution levels. And this is diagram of air quality monitoring analyzer, and the specifications are like this. Like based on the model and based on the parameter we have to measure, the specifications are valid. Like range is very important specification in this analyzer. Like for nitrogen oxide 0 to 10 ppm, and for carbon dioxide 0 to 10 ppm. For ozone it's 0 to 10 ppm. But carbon dioxide it's 0 to 100 ppm. And another one is response time. Within 90 seconds we have to guess this gas. And here for sulfur dioxide it within 120 seconds. And for ozone and carbon dioxide 75 and 50, and for this one is 60 seconds. Here this is the simulation diagram of IoT based air quality monitoring system. Here we are using, this is air quality monitoring sensor, and this is buzzer, and this is LCD display, and this is Arduino UNO, and some resistors to control the current, and this is the green LED and red LED. Green LED for safe mode and red LED for dangerous mode. LCD display in order to display the output values. And here this is air quality monitoring sensor. This sensors the pollution level around this sensor and gives alarm, or it can make sound by enable the alarm. This is a practical implementation diagram. Here we can use sensor and Arduino, and this is breadboard. We can make connections, and by coding the Arduino, we can take output by giving the instructions to the Arduino. Here we can observe that air quality is 263. Air quality level is high. That means you are in a safe mode. If it shows say like danger or air quality level is low, then we have to take measures. Conclusion is that, in conclusion, an IoT based air pollution monitoring system is a revolutionary solution that can provide accurate and real-time data about the air quality in a particular area. If you want to measure pollution in any area, by constructing air quality monitoring system takes a long time and it's expensive, but IoT based monitoring system can be portable and we can implement anywhere by less expensive cost. So by implementing the IoT based air pollution monitoring at places where we required is the best way of air quality monitoring pollution. And these are the references where I got some information for this. And Any questions, please free to contact me. This is my email and phone number. Thank you.
Okay, Sunita, are you done with your presentation?
Yes, ma'am.
Okay, fine. Your presentation was okay. And your flow was also okay. But today you were having the network issue. So in between there were a lot of noise breaking. So when you
Okay,
sit
ma'am.
for the future presentation, so try to sit with a proper internet connection. Okay.
Okay, ma'am. Sorry for that.
No problem. I can understand that. Rest from it's all from my side. Do you have any questions? So you can ask.
No, ma'am.
Okay, so I will provide your scores and feedback on your email.
Okay, ma'am. Thank you.
Okay, welcome. Okay, so Pushpak, are you there?
Yes, ma'am. Yes, ma'am.
Yes. Actually, I was saying that the supervisor of the organization is Devanshu sir, if you know. Am I right?
Yes, ma'am.
So,
Yes, ma'am.
yeah, so all the authentication and verification is in his hand. So basically what you need to do is you have to write a mail where you can provide all your information that on which date sir want to join, and you can email it on the support@hackwitha.in.
Okay,
Okay.
okay.
Okay, so from my side also, I will forward your message. You can drop all your information in chat box, right? Your full name, your email ID, and your contact number. So I will also forward your message.
Ma'am, actually, Devanshu sir is the director. How will he
Yeah.
get the time?
Actually, I know, but he's working as a mentor as well, mentor plus supervisor. So actually, I cannot be the mentor. Okay.
Ma'am, it's okay. You can also be the mentor. Ma'am, only for a short meet, it's there. Yeah.
See,
And
actually,
it's
yeah, I can understand, but actually, I have no authorization now. So I have to. Other than that, I will once talk to Neha ma'am. She's HR in company. So whatever
okay.
will be her decision, so she will contact with you. I will ask her to contact you.
Yes, ma'am. And the college will not ask your authorization as well. Uh, he
Yeah,
will
but
only ask that how is my performance, whether I'm doing an internship or not. That's all.
yeah, but actually, I cannot take any action unless there is any order from the authorization and management. Okay.
Right, right, right.
Okay.
Okay.
So you drop your information. I will forward your message as well.
Oh, okay, ma'am. Sure, sure, sure.
Okay.
Thank you, ma'am.
Welcome.
Ma'am, what should I drop?
Your full name, your email ID, and your contact number.
Okay, okay. Thank you, ma'am.
Welcome. That's okay. So I will try from my side, but you also drop the mail on that ID as well.
Sure, ma'am. Sure. Okay.
Okay. You
Thank you,
can.
ma'am. Yeah.
So we are not left with any more interns. So we wrap up our session. Thank you so much, everyone.